Hey everybody, it's Mr. N, and this is the 7.5 lesson. We're going to talk about trapezoids and kites. So let's go ahead and start with a kite. A kite is a quadrilateral with exactly two pairs of congruent consecutive sides. So these two sides right here are consecutive sides, and they're both congruent. Just like on this side, these two, BC and DC, are consecutive sides, and those are congruent. So as long as you've got two, this is exactly, notice how the definition says exactly, you got exactly these two and exactly those two pairs of congruent consecutive sides. So here are some properties that happen when we have a kite. First of all, the diagonals here will be perpendicular. So this is actually a kind of elaborate proof. Sometimes I give it as extra credit, but these diagonals will be congruent. Then we've got another thing here that we can say is these opposite angles, this angle B and angle D, just this one pair will be congruent. So B and D will be congruent, just this one pair. A and C will not, because it all depends. These angles, I can stretch it out way over here, and you can see if I leave C the same spot and stretch A to way over here, or bring in A really close, like say right here, then it's obvious this angle and that angle will not be the same. All right, let's move on. Okay, again, over here for this, AC bisects segment BD, right? It'll bisect it right here, but BD will not bisect AC. So AC will always bisect BD, but not the other way around. So that's another little theorem we have. Perpendicular and AC will bisect BD. And the reason why is, you can see this real quick. If this is a right angle, these two triangles will be congruent. So these two sides will be congruent by CPCTC. All right, let's move on to the next thing, which is a trapezoid. And the definition of a trapezoid is you have a quadrilateral with exactly one pair of opposite sides parallel. Exactly. Now, some books say different things here, but this is what we're going to go with. Exactly one pair, opposite sides parallel. So the parallel sides, these are called the bases. The other sides are called the legs. So you have this base, parallel sides, and legs on each end. These are base angles up here, and these are base angles down here. An isosceles trapezoid would be one where these legs are congruent. So if this leg went down this way and matched up this one, then you would get an isosceles trapezoid because you'd have the legs being congruent. All right. If you did have an isosceles trapezoid, we could do the isosceles trapezoid base angles theorem, which would mean these two bases would be, these base angles would be the same, and those two base angles would be the same, because again, these would be parallel, one pair of sides parallel. These are congruent because it's isosceles, and that's the result. You would end up with these two angles up here and those two angles down there congruent. And then the converse says, if these two are congruent, then you have an isosceles trapezoid. And then one more thing to cover here, the isosceles trapezoid diagonals theorem. So if you have an isosceles trapezoid, and it goes both ways, these diagonals will be congruent. So if the diagonals are going to be congruent, then you have an isosceles trapezoid. So this theorem is an if and only if theorem because it works both ways. A couple more things to cover here. So next we have the mid-segment of a trapezoid. Okay, and this is also known as the median. So this mid-segment is the median. And here's what we know about the median right here, this mid-segment. First of all, we know that this is going to be midpoint right here, midpoint right there, right? So because of that, these will be congruent here, and those parts will be congruent there. So next, since it is to the midpoints here, what will end up happening is this mid-segment will be parallel to both of these. Right? We already know that on a trapezoid, those are going to be parallel, those bases. Now the mid-segment will be parallel to it, and this mid-segment will be 1/2 of these two added up. Now, to find the mid-segment, or I'll call it the median here, It's 1/2 base 1 plus base 2. So how does this relate to the area of a trapezoid? Well, we know the area of a trapezoid is 1/2 times its height times base 1 plus base 2. Notice here, this is where I'm getting the 1/2 base 1 plus base 2. All right, let's move on. We have special quadrilaterals. This is kind of the hierarchy of everything. We've got quadrilaterals, then the special ones are parallelograms. In those you have rectangles and rhombus, and then under that a square, which is both of these. Then we have the other branch of it, which is a trapezoid and a kite. Under a trapezoid we can have an isosceles trapezoid, and a kite kind of pretty much stands alone. All right, so now let's just do some examples. All right, for number 1 here, it says that BAC is 35, BAC is 35 right in there, and BCD, this whole one is 44. Okay, we need to find ABD. Well, we know that this is going to be perpendicular, so we can say that that's perpendicular there, and since that's 35, we'll just say 90 minus the 35, and that'll give me 55. Next, DCA, well, this whole thing is 44, and we know that it will bisect it. These diagonals, they bisect them, especially since you know that these two triangles are congruent on this side, and same thing with the two triangles on the other side. So this angle will be 22 degrees. And then the measure of angle ABC, well, if we know that this is 90 and that's 22, so we're going to say 90 minus the 22, which would give me 68 degrees. All right, for the next problem, it says find the area of triangle EFG. So here's E, F, and G, and we have to find the area of this. So if this is 13, that's going to be 13 also. That's 5, that'll be 5. And we can find this height right here, right? Because we have a right triangle. This is 5, that's 13. Use the Pythagorean theorem, and you will get that piece as being 12. And a lot of you will recognize this as a Pythagorean triple anyway. So this height is 12, so you have the base as being 10, so 1/2 times 10 times that height of 12, right? Because this whole thing is 10, that's 12, and we're finding the area of that triangle. So half of 10 is 5, times the 12 will give me 60 square units. All right, over here we need to find this. We have a trapezoid, and we have to find the measure of angle Z right in there. Well, this trapezoid is isosceles, right? So this is going to be 82 here as well. And we know that adding up all four sides, I'm going to get 360. So 360 and 82 give me 164. Minus the 164, that'll result in 196 between these two angles. So divide that by 2, because again, this is going to be an isosceles trapezoid. You'll get 98 for the measure of angle Z. All right. And on to the next one. Over here, we've got Km equaling 7.5, and Mn is 2.6. So from K to M, it's 7.5, and M to N is 2.6. We need to find L to N, that piece right in here. Well, look, if this is isosceles, then these diagonals are going to be congruent. And if I know the whole thing is 7.5, then I know that K to N will be 7.5 minus the 2.6. And that'll give me 4.9. So this piece will be 4.9, and that piece will be 4.9 as well. All right, moving on. Find the value of N so that this is isosceles, which means these two angles will be congruent. So we could say 10N plus the 19 will have to equal the 12N minus the 4. So over here I get 2N. Over here, bring this over. So plus 4, you'll get 23. And N will be 11.5. Okay, find the value of X so that this is isosceles. Now, since we want this to be isosceles, I'm going to take a little bit different route here to explain this. Okay? And these two have to be 180. The opposite angles have to be 180, because if I add these two up and these two, right, I could say 2 times this x squared minus 10 plus 2 times this x squared minus 98. That has to be 360, right? If I divide the two out, I'll get this x squared minus 10 plus the x squared minus 98. That has to equal 180, right? So these opposite angles will equal 180. So let's go ahead and do this problem. I end up with 2x squared, and over here I'll end up with minus 108 equals 180. And bring the 108 over, you'll get 2x squared equals, that'll be 288, and divided by 2, you get x squared equals 144, so x is going to be 12. All right, let's move this up. Let's take a look at these next ones. On this one it says, I'm going to change my pen color here real quick, and it says BD is 7a, so from B to D that's 7a minus 0.5, and A to C is 5a plus 2.3. Okay, if we want it to be isosceles, then these diagonals will be congruent. So then 7a minus the 0.5 would equal 5a plus the 2.3. Bring this 5 over, 2a, and bring the add 0.5 to each side equals 2.8. So a is going to be 1.4. All right, next one. Let's see what we got. And it says QS is 8z squared. RT is 6z squared plus 38. Find the value of z. Okay, again, for it to be isosceles, those two must be congruent. So 8z squared would equal 6z squared plus 38. 2z squared equals 38. Z squared equals 19. So z is going to be the square root of 19. Square root of 19. All right, moving this up. One last problem here. Okay, the figure shows a ziggurat. A ziggurat is a stepped flat top pyramid that was used by a temple in ancient peoples of Mesopotamia. The dashed lines show the ziggurat has roughly shaped sides of a trapezoid. So this is basically a trapezoid, and these are 1, 2, 3, oops, my pen here, 1, 2, 3, 4, 1, 2, 3, 4. So it's evenly spaced in between. M and N is evenly spaced. So give the vocabulary term, that's going to be the median. Or you can also say the mid-segment. So that's the proper vocabulary term for M to N. All right, and that's pretty much it. So hopefully this wasn't too bad. Hit that like and subscribe button, and I'll see you guys in the next video.